series hasn't seen its finale just yet. If you haven't watched the previous BVM monitor or PVM BVM monitor series, I suggest you go and check them out now. I toiled over them. No, to check them out so you know the context of this video. Because there were a few systems that actually didn't work, with the BVM, and it's 3 systems to be specific. The ZX Spectrum, the PC Engine with the Terra Onion expansion, RGB out from there, and also the BBC Micro. So those 3 are the only ones out of all my systems that are having trouble with the BVM. Now, I know that these are sync issues. Exactly what they are, I've been trying to research. My friend and I have been banging my head as well and brainstorming every now and then, but I've been doing a lot of research on this. Now, one of the things which I did decide to get to try, not just to try out for this, but also because I was curious about it. I saw one of these on eBay and it was going cheap, and I know people have been after these for, and they're not normally that cheap as I saw them, so I thought, okay, I'm just gonna get it anyway. Now, this converts an RGB signal to component. Now, I do know the basics of, the sync concept, why it's there, so forth, but I don't know, the nitty-gritty details of it. So I am learning as I go along, and I'm learning quite a lot in this series, actually. So this, I thought to myself, okay, as much as I wanted the RGB to component to try that out, as I was curious about it, I also wanted to see if it would make any difference, because, to change RGB to component, what happens is, it has to re-encode it. There is no sync out separately. Basically, green is calculated by, blue and red. So, and this plug is actually not green, it's sync. So, yeah, the encoding is totally different. So I thought to myself, okay, let's try this. Maybe the conversion to component will solve the issue for these, these problematic sync signaled freaking computers and consoles. Unfortunately, when I tried it, unfortunately the same thing. It seems that it must just carry the same signal from the the sync signal from the RGB in to here. So that was a shame. However, I did out of curiosity try the RGB to component itself, and wow, it actually improves the picture. It looks nicer, if you know what I mean. It looks more richer and more, Now, one of the things which I thought to actually do with regards to, these is do a mod for this, which gives it an S-video out and use S-video instead. Even though that's not, a success story in a way, it's kind of like a way around the issue rather than solving the issue. I understand that. And I also, thought the same about the Spectrum, do an S-video mod on it. I mean, it is possible somebody's done it. I've searched around. Yes, I researched freaking hours on this and trying to find a way to sort it out. So yeah, I came across and I'm not sure about the BBC Micro. I haven't checked for that yet. But I thought to myself, is making each of these devices S-video a cop-out or what? Let's try everything we can with the sync signal, and then, then that can be the last resort. At least it's something, Now, with regards to the PC Engine itself, people always say that the actual issue is with the Terra Onion SSDS3. Others actually say that the issue is, not with this as per se. It's more to do with the RGB signal coming out of here. which I'm not sure if this actually does anything to the RGB signal or not. I'm not sure which it is. I'm not going to comment on that. But either way, the sync signal coming from the PC Engine overall is not suited for that. It just seems to be, you know, just out of spec for this monitor. I mean, don't get me wrong, it will work on a PVM. It worked on this PVM, the small one, and I'm not actually, I didn't check it with the other one. I should have done, you know, the one which I returned. I should have tested a lot of the systems on there, but hey, you live and learn. Now the issue with the Spectrum over here is that it has a TTL output. Now the output is going to be out of spec, you know, probably be, even if it's a little bit of a higher voltage, you know, so forth, or if the line is a bit noisy, so forth, you know, I need to get myself an oscilloscope. I'm really, you know, wanting to save up to get myself one of those because, you know, that'll help me see what the signal is actually like rather than, you know, just taking guesswork and figuring out stuff. You know, that's the one issue which I have. Now, if you were to actually look at the cable of this is the part which, you know, input, and this goes into the PVM. And if you ignore the two audio cables here, the black and the white, you have yourself the RGB, and then you have the sync. Now the sync is yellow. That is because this is actually on the pin here. It's connected to the composite pin, which the composite pin is pin 20 on this. My guess is some of these systems like this or like this are giving the wrong signal out, giving the wrong sync signal out, you know, which BVM probably, PVM probably and other TVs probably are fine with it, but this BVM is not. That's the freaking annoying thing about this BVM. So yeah, it's drawn everything out. So what I want to do is I want to try something, a little thing which I bought from Retro Gaming Cables. Now I decided to order a sync blaster. Sync blaster, that's its name, but it's actually a sync stripper from Retro Gaming Cables. They actually sell these type of cables, these for PVMs, BVMs, so forth, with this actually built in to the thing. This one doesn't. This just goes straight in there. And when ordering, they asked if I have any comments, or if I don't, just tell them they're awesome. So I told them they're awesome. I hope that made somebody smile. First things first, let's open this out. Open it quite a few times. So we need the composite, which is pin 20, to go in here, and also this needs a power to power that little chip there. This little dude comes with 4 points, solder points, right? So what you need to do is this part here, this is the socket, and this is the input. This is where from your SCART matrix the signal goes into here, and then, you know, goes through there into your BVM monitor. So what you need to do is pin 20 on this. Pin 20, which is this, desolder that from the yellow wire here. The pin 20 goes inside the in, on the in point. You need to solder the pin 20 onto the in. And the out, that's this one, bottom one, goes to the yellow wire. So you're putting this board in between the pin 20 and the yellow, right? Now then, you need to power this board then. So you need to get a wire and solder pin 8 to the power pad here, nicely labeled, all of them. And the ground is, you know, pin 17. Right, so 1, 2, 3, 4. This 4th pin here, that is the 12 volt out. So let's tin that first. Now one thing I've realized is that the positive and negative wires are just way too thick. So I decided to, you know, use these thinner wires instead. So the white is going to be positive and the green is going to be negative. Yes, I know it's confusing. I actually do need to get some, you know, wire and stock some adequately sized wire. That's kind of a bit ridiculous. So that is, I'm going to use video ground for that, pin 17. When the SCART is connected and the outer casing, which is supposed to be ground, shut up you. When the outer casing is supposed to be ground, that actually has continuity with the video ground. Right, so pin 20 on the SCART, which is this top one here, the one on the point, that's how I remember it. The little part that sticks out here. That one, that pin next to it is pin 20. So that goes into the in on the board, the in here, and then the out actually goes where it was connected, is into that sync. Sync. Oh my god, it's working! It just worked. Where are you? Okay, it's just there. Oh my god. My goodness, it's getting close. It's just a freaking sync type. Come on, stay there, please. No, I don't know, is that 470 ohm resistor? Do I need to take that off? Is that what it is? Does this thing require TTL sync or what? So now I'm wondering, is it the sync stripper that's done it, or is it putting these 75 ohm terminators in? I'm wondering if the signal from the spectrum is just a little too weak for this, because I know when I measured the sync voltage, right, on the pin 20, yeah, from the sync, directly from the sync latch spectrum, it was just under 1 volt. It should be 1 to 2 volts or something like this. So it was just under, you know, just shy of a volt, and not that much. It was like, you know, 0.9 something. So, you know, it 1 volt more or less. So it may just be that it's just a little low. And you know what sucks on this? The fact that you can never do on the RGB channel, on the RGB card, you can never do VCR mode, which would apparently solve the issue with the PC Engine at least. Okay, so what I've done here is I've bypassed the resistor, the output resistor, which is 470 ohms, and I've added a 500 ohm trimmer or potentiometer on, you know, from the output to that. So what I can do now is I can set different values and then test them out just to see if it kind of makes a difference. Now what I've done now it was the output resistor was 470, right, ohms. Now I've set this to 450 ohms. I know it's a very minuscule amount, but still I want to be safe, and I'm going to see if the image stays on longer. Do you know what I mean? So because this is working as a voltage divider with the internal resistor of the monitor, so it's not necessarily, you know, the lower the resistance, that means the more will go through it. I don't think it works like that, as far as I'm figuring anyway. Okay, so I've put a 1K potentiometer in there because the 500K just didn't make too much of a difference. It might be a bit too strong. It might not be weak, it might be too strong, it might be clipping. So it's sort of, that's not recognizing what the frick this signal is because it's clipping and distorting, as far as my understanding. I'm trying to, like, you know, visualize a oscilloscope here in my mind because I cannot I don't have one. No. Funny how it comes on when I touch the variable resistor. That's when it starts flashing and trying to come on again. But I wonder if it needs stabilization. Right, so the next day, and I have an oscilloscope. Hey, look, you can see me. Hi. Anyway, so yeah, this didn't just, like, you know, walk all night and end up on my doorstep today. I knew at some point I had one. I went up in the attic and I just managed to get it. I remember this having some sort of fault with it or something like this. So yeah, it may not be perfect, but hey, it's better than freaking nothing. So what I want to do now is test the sync signals. I have a look at the sync signals, you know, what they look like, so forth. And most importantly, comparing a sync signal from a system that works with a system that doesn't work. You know, that'd be interesting to see what it looks like. And also measuring it with and without the sync stripper. So first we have the Mega Drive, and that is a system that works perfectly without any issue or anything like this. So Mega Drive sync before the sync stripper, with no sync stripper on. Okay, interesting. So that's 1 volt per division one division is one of those squares, so that's 1 volt. I haven't messed around with this oscilloscope for freaking years. So that's 2 volts there. You can see that's what it looks like. And that is before the sync stripper. Now will be after the sync stripper, but before the 470 ohm resistor. Right, so this is basically from a working system. Now then, let's try the same thing with the spectrum. Freaking Oscilloscope seems to be working fine. I remember it having some sort of fault. Anyway, let's connect this in. Sync signal from the spectrum. Oh, okay. So look at this now. This is a different signal. And also it's quite a small signal. It's just short of a... That's the maximum the freaking intensity goes. It's so thin. Okay. So after the sync stripper, even freaking smaller signal. Diddly now. You know something? Okay, let me zoom in. This is too freaking diddly for you. Okay, let me just shut the blinds and become a vampire for a moment. Right, okay, so spectrum before the sync. Before the sync stripper. Now that you can see it is... It's like 1 volt, kind of. Hitting 1 volt. Just, I remember when I tested this with a meter, the multimeter, it was just under a volt. It was just shy of a volt. It was like 0.9 something. So I know it's like less than what is probably required. So now the output of the sync stripper before the 470 ohm resistor. And it's freaking tiddlier. Smaller. Probably that explains why the 75 ohm thing worked. Now this is after the resistor. As you can see here, it's not even a freaking volt. I'm figuring this is giving out the right, kind of signal, but it's just less. Now, I'm curious about this. PC engine. Let's try that next. Right, so PC engine before the sync stripper. Ooh. That should work. Well, voltage wise. Okay, let's try the output of the sync stripper without the resistor, 470 ohm resistor. Well, the sync stripper definitely reduces the voltage of it. So, I mean, 1 volt should be enough for it to work, technically. 470 ohm resistor. Same, it has this output. So why does that output not work? Bear in mind, I've got no experience with sync signals, so yeah, anybody who knows what it's supposed to look like exactly. I mean, I know it with terms of voltage, what it's supposed to be, but what it's supposed to look like. Okay, so I'm gonna switch the BBC Micro on without the sync stripper. Also, do excuse the sound of kids screaming for no apparent reason. It's just kind of like just under 2 volts. Very different looking to the rest. Okay, so that is after the sync stripper, but before the 470 ohm resistor. What the freak? Is barely anything there. There's not even 1 volt. Now I can see why the BBC Micro didn't like the sync stripper. Freaking nothing came out. Right, I'm gonna do it after the resistor. So this includes the resistor. Yeah, same. It's under 1 volt. So the voltage is really off for a start. That's probably why it detected, okay, almost no sync. Okay, that's the BBC Micro. Let's try something else that works, just to confirm a good sync signal. Okay, so now an Amiga 500. Ooh, nice healthy sync signal. I'm trying to know what a nice sync signal looks like. It kind of looks like the Mega Drive one. And it's at 2 volts. So I'm figuring that sync signals tend to be around 2 volts. Maybe 1 to 2 volts or something like this. Okay, so now is the output of the sync stripper before the 470 ohm resistor. What the freak, where did that go? Where's the top part of it? What the freak? The side. That's how many? It's like 1, 2, 3, 4, 5.5 volts. It's like way high. Okay, let's try it after the 470 ohm resistor. Wow, okay. So it takes it all the way up to like freaking 5 volts. That's not good. I like how it bobs every time the disc clicks. So then the conclusion here, the matcha tea coming out from the bottom. So the conclusion here, the sync stripper had some interesting results. It kind of works with the Spectrum only. However, another thing which I've noticed is that it only happens with the sync stripper and with a 75 ohm terminator. Now, with this monitor, I need to check if it already has automatic termination, automatic, 75 ohm termination. And if I'm putting this on top of this 75 ohms, I'm halving the freaking resistance. So yeah, I mean, it was a little closer, but I don't want to, you see, I'm also afraid of screwing up my monitor, right? That's why. That's one of the reasons why I'm not like, wholeheartedly. If I had a spare freaking BVM and if they were like, 10 a penny or something like this, then yeah, of course I would buy like freaking 10. I had better get some sleep because it is like 7 a.m. I lost an hour, didn't I? Daylight savings time clocks went forward tonight. So I lost an hour. Right, before I call it quits, do check out my Facebook page, do like it, add it. Also, do follow me on Twitter and on SoundCloud and on Flickr as well. Also, thanks so much for your likes, your shares. Do leave your thoughts in the comments below. Don't forget to check out my other videos because there's a big freaking library now. And do subscribe for more. And don't forget to hit that bell icon. Also, a big thank you goes to my patrons. And yeah, if you wish to see my patrons' websites, YouTube channels, they're in the description below. So, for now, I will say buenas noches, buenos freaking días.